Hi there. I've decided to make a video instead of doing pictures like the assignment said, just because I think it would be easier to be able to show you what I've done with my project. I've labeled all of the walls here for the inner ear. We're going to start with the lateral wall. This is the wall of the middle ear that's closest to the outer ear. So with this, we have the tympanic membrane, which is the eardrum. Connected to this is the tensor tympani, which is the muscle that tenses up this membrane. And this is the canal for this muscle is on the anterior wall, so it fits together something like this. And so the anterior wall is closer to the front of the head. So if you can imagine that muscle is towards here while the eardrum is here. On the eardrum, the malleus bone, which is one of the ossicles, is connected to it. And I've drawn these here. It's kind of hard to see them because they're freestanding, but I'm going to hold a piece of paper up. The malleus is the bone that's closest to the eardrum, and that is called the hammer. Connected to that bone is the incus, and that's called the anvil. And then the anvil is connected by a ball and joint socket to the stapes, which is shaped like a stirrup. And all three of these bones are the smallest in the body. And when sound vibrations hit the eardrum, it vibrates, it turns into mechanical energy and vibrates these bones in a way that amplifies the vibrations. And so these bones eventually send the vibrations to the fluid-filled inner ear, which interprets it as sound. Then let's look at the anterior wall where the canal for tensor tympani is located. On this wall, we also have the auditory tube and the internal carotid artery. So there's not much going on in this wall, but it's the wall that's closest to the face. Across from that wall, we've got some interesting things happening. We've got the tendon of stapedius, stapedius, which is a tendon that connects to the stapes bone, and that holds on to it so that if someone hears a loud sound, and it might run the risk of giving too much vibration to the inner ear and damaging it, this tendon tenses so that the chain of movement in the bones is stopped. The pink line, dotted line that's running on this wall is the facial nerve. This nerve originates in the floor of the middle ear cavity, which I'll show you soon. And then we also have the additus ad antrum, which is, hold on here, let me look at my notes. That's the opening to the mastoid where there's air cells. And then I made the tendon of stapedius 3D, and when you connect the bones to it on this model, it in theory touches the stapes bone. It's hard to see on the camera. Next, let's look at the floor here. We've got the stylomastoid foramen, which is a hole in the bone where the facial nerve comes through. And then we also have the jugular vein, which is a really prominent feature on the floor of the middle ear. And then we'll look at the medial wall. This is the wall that if you were standing inside the middle ear, your back would be towards the pinna, and you would be facing the inner ear, or like the inside of the head. There's a lot going on in this wall. I'm going to try to get as close as you can so you can read what I've written here. On the medial wall is the lateral semicircular canal, which is right here. Underneath that is the facial nerve canal, which is a bony structure where the facial nerve runs through it. That's the purple right there, and you can see the facial nerve that originates in the floor and goes over the posterior wall and gets onto the medial wall right there, and then that extends to the geniculate ganglion. I don't know if I pronounced that right, And near to that structure is also the greater petrosal nerve. There's also a lesser petrosal nerve that runs very closely to the tympanic plexus. And the tympanic plexus also has a nerve associated with it, and that's the tympanic nerve, which is the red kind of squiggly thing that's happening on this model. The green here underneath the facial canal is the oval window, and underneath that is the round window. And the stapes bone has the perfect shape to fit into that oval window. And I'm going to try to, this always turns out to be really dark in this room, but hopefully you'll be able to see that these bones kind of stand suspended in the middle ear, and when you look at it, the stapes bone fits directly into the oval window. And when these series of bones vibrate, they send the vibrations to the oval window, which translates into the fluid-filled inner ear and translates to sound. And that's the video.